7.5 is still dealing with fractions, and we look at equations that have fractions in them now. So let's start here. If you watch the video for this section, then you'll know that clearing fractions is one of the keys here. Clearing fractions. And if you took Math 098 or even Algebra 1 in high school, then when we have equations that have fractions, one key thing we want to do is make the fractions disappear, but we have to do that in a way that keeps our equation balanced. So remember, with equations, if we do something to one side, we have to do the same thing to the other side. Also with equations, the opposite of dividing is to multiply. So if we multiply both sides by 8, let's see what's going to happen. If we multiply the first term by 8, 8 times w over 8, the 8 on top, the 8 on bottom cancel, leaving us just w. Then we also have to multiply the second term by 8. 8 times 3. On the right side, we have 8 times 8, which is 64. So by multiplying everything by 8, we made our fractions go away. We have a new equation. It's equivalent to the first one because we did the same operation on both sides, but it's a simpler equation because it doesn't have fractions. So to get w by itself, the opposite of adding is to subtract. So subtract 24 from both sides. Those cancel. So we get w is 40. And with all equations, it's a good idea to go back and check our answer. If we do, that is going to work for this equation. Notice 40 divided by 8 is 5. 5 plus 3 is 8. So 40 is the number we're looking for. Let's take a look at this one. In the previous one, we only had one denominator that showed up. So it was easy to figure out what number we needed to multiply by. Here we have two different denominators. We have 5 and 6. So they may have, in the video on this section, described it as we need to multiply both sides by the least common multiple. So what is our least common multiple? What is the smallest number that 5 goes into and that 6 goes into? So multiples of 5 are like 5, 10, 15, 20, 25, 30. Multiples of 6 are 6, 12, 18, 24, 30. Notice the first number that's in both lists is 30. 30 is a multiple of 5. 30 is also a multiple of 6. So that's what we're looking for. So we're going to multiply both terms on the left side by 30, and we're going to multiply the right side by 30. Now the right side is the easiest one because there's only one term. So if we multiply the right side by 30, the 6 on the bottom goes into the 30 on top 5 times. 1 times 5 is 5. On the other side, we have two terms, so we have to multiply each of those by 30. So we're going to do 30 times x minus 6 over 5. And we're going to do 30 times x minus 5 over 6. So for the first one, 5 goes into 30 6 times. For the next one, 6 goes into 30 5 times. So now we have a new equation that doesn't have fractions in it. So to solve this, we need to get rid of our parentheses. So distribute 6 times x, 6 times negative 6, 5 times x, 5 times negative 5. Our equation has x to the first power, so we want to collect all of our x's on one side, our numbers on the other. But before we do that, let's simplify. On the left side, we have 6x and 5 more x's, so we have 11x. We have negative 36 and minus 25. If we rearrange that, put those together, that makes minus 61. And we still have our 5 on the other side. Okay, since it's a linear equation, x to the first, we want to get that term by itself. So move the 61 to the other side. So those cancel. And then to get x completely by itself, the opposite of multiplying is to divide. So divide both sides by 11. The 11s cancel. 66 divided by 11 is 6. So we have x by itself, so we have our solution. The key thing here is, what is our common multiple that we can use to make our fractions go away, to make our denominators disappear? Okay. Here, we want to know what is our least common multiple. And we probably could do this one without writing this stuff over here on the side, but what are our denominators? A minus 2 here, A minus 2 here. So the question is, are we going to need to multiply by 1A minus 2 or by 2A minus 2s? Well, how many A minus 2s would we need here to make that denominator go away? And how many A minus 2s would we need in this fraction to make the A minus 2s go away? Because when we multiply, remember every term is going to get multiplied by whatever we pick. So do we need 2 A minus 2s here? No, because we're only going to cancel one out there. Do we need 2 A minus 2s there? No, because we're only going to cancel one out there. So we only need 1 A minus 2 to multiply everything by. So we're going to multiply the entire left side by A minus 2. And then we're going to multiply the right side by A minus 2. We're still equivalent because, like a seesaw, we have to do the same operation on both sides for it to stay balanced. Well, we are. We are multiplying both sides by something, and the thing we're multiplying by is A minus 2. So we're going to do A minus 2 times the first term. So let's call that 7 times A minus 2. We're going to do A minus 2 times the next term. And on the right side, we're going to do A minus 2 times that term as well. So now we need to go through and reduce where we can. The first term, we can't, there's not a fraction there, so nothing to reduce. So let's go ahead and multiply that out. 7 times A, 7 times 2. For the next term, we have an A minus 2 on top and an A minus 2 on bottom, so we're just left with the plus 12. On the other side, we have an A minus 2 on top and A minus 2 on bottom, so we're left with the 6A. So now we have a new equation that has no fractions in it. We have nothing on bottom. Our equation has our variable to the first power, so eventually we're going to get our letters on one side, numbers on the other. Before we do that, let's go ahead and combine those. Opposite signs we subtract, take the sign of the bigger. Doesn't matter which side we're going to get things on, let's get the A's on the left. So if we take 6A away from here to make that go away, we would take 6A away there. So 7 minus 6 is 1A. On the right side, 6 minus 6 is 0. Now to get A completely by itself, add 2 to both sides. So the 2's would cancel, so we get A equals 2. Now we have to be careful. We've been a little sloppy on the other ones because it didn't give us a problem. But notice we said that our answer is a equals 2. Now, if we look at our original problem, let's see if a can be 2. Notice if we were to check by putting a 2 everywhere we have a, we run into a problem. In this denominator, we would have 2 minus 2, which is 0. We can't divide by 0. Same thing here. We would have 2 minus 2, which is 0. We can't do that. So that particular solution doesn't work. That number is not in our quote-unquote domain, even though this is not a function. So that is not a value that can be a solution to this equation. Where did that number come from? We wrote a new equation, and that number is a solution to that new equation. And usually, our equations are going to have the same answers, but occasionally, we're going to get an answer that works for the new equation, but not for the original. So we always have to look at our final answer to see if it's an acceptable answer for our original equation before anything is done to it. And in this case, it's not. Well, then what is our solution? If this one is not the answer, then what's the answer? Well, if we go down to the end, did we get any other answers? No, we didn't get any other answers. We found out that that one doesn't work. So if the only one that we got doesn't work, that means this equation doesn't have an answer. There's no solution to it. So we did all that work to find out that this equation can't even be solved, or that there's not an answer to it. All right, let's take a look at this one. All right, so we need to find out what do we need to multiply by to make our denominators go away. So I see some things on bottom. I see 3 x's, and I see a 7. So to make the 3 x's go away, I'm going to need to multiply everything by 3x. And let me do it like this, just for illustration. So whatever we multiply one side by, we have to multiply both sides. And on the left, if we multiply by something, each term gets multiplied by it. So what are we going to multiply by to get rid of that 3x? Well, if I put a 3x on top, that would make that go away, but I have to do that for every term. So we could multiply everything by 3x. That makes those cancel, but we still have a 7 on bottom. So we also need to multiply everything by 7. That would make those go away. So now everything on bottom is gone. So the number that we're going to multiply by is 3x times 7, also known as 21x. That's our least common multiple. That's our least common multiple. So notice every term got multiplied by the same stuff. 3x times 7, or 21x. And that canceled out this denominator. The 7 canceled that one. The 3x canceled that one. So to see what we have left, we have 19 times 7. Let's see, 133. We have 2 times 3x. And on the other side, we have 13 times 7. Okay, we made our fractions go away, so subtract 133 from both sides so that the 133s cancel on the left. Divide both sides by 6 to get x by itself. A negative over positive is negative. 42 divided by 6 is 7. Then we would just have to check to see if that answer is okay. If we plug a negative 7 in place of x, is that going to give us a problem? If we put a negative 7 there, 3 times negative 7 is not 0. There's not a variable there to plug in a negative 7 in. If we put a negative 7 in there, 3 times negative 7 is still not 0. So as long as it doesn't make the denominator 0, then if we did things correctly, that answer is okay. That answer is okay. Right, let's take a look at this one. So let's start out by factoring this denominator so that we see what factors that denominator is made of. That's going to help us know what we need to get rid of. So r squared is r times r. Negative 21 has to be a positive times a negative, and that's going to be 7 and 3. 7 times negative 3 is negative 21. 7 minus 3 is 4. So the factors that we need to get rid of on bottom, we need to get rid of an r plus 7. Some of those fractions have an r plus 7 on bottom, and some fractions have an r minus 3 on bottom. None of the fractions have more than one of these, so we don't have to multiply by 2 of those. None of the fractions have more than one of these, so we don't have to multiply by 2 of those. So we're going to multiply everything on the left by that, and then we're going to multiply the right side by that. So let's start out by copying down what we have on the left. We have 3r minus 3, and let's write that denominator as r plus 7 times r minus 3. Then we have plus 4 over r plus 7. And then on the other side we have 3 over r minus 3. So we're going to multiply both of those terms by r plus 7, r minus 3, r plus 7, r minus 3, and then on the other side, we're going to multiply that by r plus 7, r minus 3. So for our first fraction, we have an r plus 7 on bottom and 1 on top. We have an r minus 3 on bottom and top, so those cancel, leaving us 3r minus 3. The next fraction, we have an r plus 7 on bottom and 1 on top, leaving us 4 times r minus 3. Well, how do we do 4 times r minus 3? We distribute. 4 times r, 4 times minus 3. On the right side, we have an r minus 3 on bottom, 1 on top. Those cancel, leaving us 3 times r and 3 times 7. So we have a new equation that no longer has fractions in it. So we want to simplify the left. We have 3r plus 4r. 3 plus 4 is 7. We have a minus 3 and a minus 12. If we rearrange these, minus 3 minus 12 is negative 15. Notice I didn't do the opposites. I just essentially rearrange that. Since they're on the same side already, we don't do the opposites. We just change the order and combine like terms. So we want all of our letters on one side. So let's subtract 3r here and 3r here so that we don't have any r's on the right. So that gives us 4r minus 15. Our r's are on the left, so we want our numbers to the other side. So let's add 15 to both sides. So our 15s are gone. So that leaves us 4R. And on the other side, 36. And then to get R by itself, divide both sides by 4. So R is 9. R is 9. And 9 is okay, because if we were to plug a 9 in for any of those R's, we're not going to get a 0 on any of the denominators. So unless we made a mistake somewhere, that is our answer. That's the solution to our equation. It doesn't make the denominator 0, so that one is okay.